Today we are going to discuss about heap sort using max heap. Sorting is rearranging elements either in ascending order or in descending order. So either ascending order or descending order. So there will be an array and the elements of array need to be rearranged either in ascending order or in descending order. For example, we are going to rearrange the elements of an array in ascending order using heap sort, that is using a max heap. So first of all, we have to create a max heap with the given array elements. So array elements are converted into a max heap. So whatever the elements, unsorted elements we are having, we have to build a max heap. After creating max heap, we can know that the largest element is there at root position. The property of max heap is one is shape property, the other is heap property. Shape property means it should be like a complete binary tree. Complete binary tree. And heap property means parent is greater than children. See, this is a heap, max heap, where root is greater than its children. Then 45, 45 is root of left subtree. So 45 is greater than its children. 77 is root of right subtree. So 77 is greater than its children. So everywhere the value of a node is greater than its children, child elements. The algorithm to sort elements of an array using heap sort. Heap sort algorithm is as follows. There are 4 steps. Step 1, build max heap. Whatever the array, unsorted array, unsorted array, unsorted array is converted into a max heap first. After creation of a max heap, swap last element with root. So root is the largest element. Root element is swapped with interchanged with the last element of the heap. Then reduce the array size by 1. One element is fixed in its proper position, so we have to perform the procedure with the remaining n minus 1 elements. So reduce the size, array size by 1 and reheapify the remaining elements to make it max heap. The remaining elements are made again max heap. Then repeat step 2 and step 3 until size of heap is 1. If size of heap is 1 means it is already sorted. So we repeat this process until every time we are reducing size by 1, so that somewhere the heap size becomes 1. Whenever it becomes 1, you stop the procedure. Suppose if we need to rearrange the array, this is the unsorted array, assume that unsorted array 77, 24, 67, 45, 34, 12, 96. If wanted to rearrange the elements in ascending order, in sorted order, first of all, we have to create a max heap. Say, this is the max heap. The figure shows the max heap. So 96 is in its proper position, that is root element. Then 45, 77, 24, 34, 12, 67. How to create a max heap? I'm going to explain. See here, once max heap is created, the heap can be represented as an array like this. So see, this is unsorted array. Unsorted array. Array contains elements from level by level. In the level 0, it contains 96. Level 1, it contains 2 elements 45, 77. Level 2, which contains 4 elements 24, 34, 12, 67. All 7 elements are there in the unsorted array. Now we are going to rearrange these elements in sorted array in ascending order, just like sorting. So here the procedure of sorting is said to be heap sort, because we are converting the elements into a heap and then we are going to sort it, so it is said to be heap sort. So building a max heap, first of all we have to create a max heap using the unsorted elements. Assume that 77, 24, 67, etc. So normally, initially, we assume that max heap is an empty heap. Empty heap. Then insert 77. If you insert 77, where we are going to insert the first node, so 77 becomes root. Then insert 24. So 77. To insert 24, normally we create a node and we add at the end of the heap. 24 is added at the end of the heap, and every time you add, you have to check whether it is satisfying shape property and heap property. Is it satisfying shape property? Yes. Root and left value. So it is like a complete binary tree. Complete binary tree. Then heap property, parent is greater than child. So 77 is parent, 24 is child. So it is satisfying both the properties. Then insert one more element. 77, 24 and 67 will be inserted at the end of the heap. Now check, is it satisfying shape property? Yes. Is it satisfying heap property? 77 is greater than its children. So heap property also it is satisfied. Then insert one more element. What is the element to be inserted? 45. Say 45. Insert 45. 3 is 77, 24, 67. 45 will be inserted in the next level starting from first location left to right. So 45 is inserted here. Check whether it is satisfying shape and heap. Shape, heap. Shape is satisfied. It is following complete binary tree. What about heap property? 77 is greater than 24 and 67. Okay, but 24 is not greater than 45. So here also it should satisfy the heap property. So interchange them. So you may change 45 and 24 interchange. So that now it is satisfying shape property and heap property. Next. Insert next element. Insert 34. Now we are going to insert 34 as the next element. 45, 67, 24, 34. Now check, is it satisfying shape property? Yes. Is it satisfying heap property? Heap property. 77 is greater than 45 and 67. 45 is greater than 24 and 37. Yes. Then insert 12. 77, 45, 67, 24, 34. We insert 12 at the end of the heap. So end of the heap means next possible location is left of 67. Now is it satisfying the property? Yes, it is satisfying the properties. Both the properties, shape property and heap property. Shape is a complete binary tree. Heap is parent should be greater than children. 77 is greater than 45. 77 is greater than 67. 45 is greater than 24. 45 is greater than 34. 67 is greater than 12. Yes. So two properties satisfied. Next insert one more element. Then 96 to be inserted. 77, 45, 67, 24, 34, 12. The next possible location is right of 64, 96. Now, is it satisfying shape property? Yes, it is satisfying. Say shape property, it is complete binary tree. Then, what about heap property? 77 is greater than 45 and 67. 45 is greater than 24 and 34. 67 is greater than 12, but 67 is not greater than 96. So, interchange them. 96, 67. 7. Now is it satisfying heap property? No. 77 is less than 96. Again interchange these two. So 96 is made root value. This becomes 77. So the final heap is like this. So 96 root, 45 is left subtree, 77 is right subtree, 24, 34, 12, 67. So now we have constructed a max heap where it is satisfying shape property. Shape is complete binary tree. Heap property, parent is greater than children. Now this can be represented in array as, say, the array elements are placed in the array just like whatever the elements that are there in complete binary tree. 0th location is root, first location, level 0. Then level 1 contains two elements. Mention the two elements here, 45 and 77. Level 2 contains four elements, 24, 34, 12, 67. Make the four elements here. So we have seven elements. All the seven elements are placed in the array, but the array is not a sorted array, unsorted array. Unsorted array. Now we are going to sort this using heap sort, right? So first of all, we have constructed a heap using the unsorted elements. Now we are going to rearrange the elements in the array in ascending order using heap tree, max heap tree. Now let me explain how to rearrange the max heap into a sorted array. Now we have converted a max heap, we have created a max heap from the given values, which is root value is 96, etc., etc. So array is specified, array. The max heap is represented as an array 96, 45, 77, 24, 34, 12, and 67. We know that the largest element is root element. Root element is now uh, interchanged with the last element of the heap, because in a sorted array, the largest element will be placed in the last position of the array. So we are going to replace or interchange root element, the largest element, with the last element of the heap. So 96 is interchanged with 67. 67, 96. So here 67, 96. So 96 is fixed in its proper position. Now we need to rearrange the remaining elements into again sorted order. Every time we fix one element in sorted order. Say this is unsorted and 6 last element is sorted, because 96 is the last element. So it is fixed in its proper position. Now see, leaving 96, because it is already fixed, the remaining elements we have to readjust them into max heap. So reheapify to make it max heap. Readjust elements to make max heap. So to make max heap means the largest element should be parent. So here 67 is less than 77. So again replace, interchange them, 77, and this becomes 67. 77 is greater than 45 and 67. 45 is greater than 24 and 34. So you will get this tree. Now see the second tree. Tree number 2. 77. 96 is already fixed. In the array also, assume that it is containing unsorted and sorted elements. See, 77 is the largest element and interchange with the last element. 77 is interchanged with 12, 77 and 12. So here you will have 77 and here you will have 12. Two elements have been adjusted as sorted. The remaining elements unsorted. So again leaving these two elements, readjust the elements. So largest element should be its parent, 67, 45. 67 is the largest element, so 67, and you will make 12 here, 45. Yes. So now again you will get this kind of array. So here already two elements are sorted, 77 and 96. Remaining elements are 67, 45, 12, 24, 34. 67 is the largest element and it is swapped with last element of the heap, 34 and 67. So 67 is made last element. So here you'll get 34. See, three elements have been sorted, 67, 77, 96. Remaining four elements are there. Again, these four elements readjust to make it max heap. So if you readjust this to make max heap, largest element will be moved to root position 45. 45 is, see figure 4. 44 is root and 34 is next value like this. So three elements are already sorted, 67, 77, 96. Remaining four elements we have to make adjust, rearrange into sorted order. We know that 45 is the next largest element. Replace or interchange with last element. So 45 is placed in last element of the heap and 24 becomes root element. So here 45 and this becomes 24. So these four elements are already sorted. So 45, 67, 77, 96. Now there are three remaining elements. Again readjust them, 24, 34, 12. So it should be largest. So it becomes 34 and this becomes 24. See, 34, 24, 12 and 4 elements already rearranged. Now 34 is the largest element. Interchange with last element of the heap. Here last element is 12. So 30, this becomes 34 and this becomes 12. So 34 occupied position of 12 and this becomes 12. So 4 elements, 5 elements have been sorted. So these are sorted. Unsorted elements are 2. So 34 is also sorted. So these two remaining elements. Again readjust them to make a max heap. So 24 becomes root, 24, 12. These remaining elements are sorted and the remaining two elements are unsorted. 24 is swapped with last element of the heap, 24, 12 and this becomes 24 and this becomes 12. See, 24, 12, 34, 45, etc. So all are sorted. So elements have been sorted. And once it is also made, the array consisting of only one element. If an array consisting of only one element means it is already sorted. Step once again. Two elements are remaining. 24 is the largest element and it is swapped with, see, this is unsorted and this is sorted. So unsorted and sorted. Largest element is swapped with last element of the heap, 12, 24. So these two are interchanged, 12, 24. So 24 is also inserted in the sorted array. It is fixed in its proper position and remaining element is only one element in the unsorted position. If an array consisting of only one element means it is already sorted. Now see the final one. So 12 is its root, remaining elements are 24, 34, etc., etc. See the sorted array 12, 24, 34, 45, 67, 77, 96. So they are in ascending order. That to sorted array. So why it is said to be internal sorting? We have used max heap to sort elements, which is said to be heap sort. But why it is said to be internal sorting means we have not used any external array to store the ascending ordered elements or elements in sorted order. The same array we have used to rearrange the elements. That's why this kind of sorting is said to be internal sorting. To sort elements of an array, we have used max heap max heap. So it is said to be heap sort. What we did here, we have first constructed a max heap. Then we know that the max heap contains largest element as the root element. The root element is swapped with last element of the array and adjusted all the elements again like a max heap, leaving the last element of the heap. And this procedure is repeated till the unsorted heap consisting of only one element. If a heap or array consisting of only one element means it is already sorted. How this in this way we can sort all the elements in ascending order, which is said to be heap sort. Thank you.